ENCOR Section 22 Summary Challenge, Network Services. Different NTP restrictions can be configured through ACLs on Cisco devices. Match the restriction keyword with the restriction it applies. And we have 4 restriction modes listed here and description what they do. Okay, I didn't feel, when I read the course for this particular topic, I didn't feel like it was crystal clear, so I had to do a little bit of additional research. And what I was able to understand is with NTP, there are 2 types of exchanges which are treated differently by these 4 different modes, okay? These 2 types, one type is sort of internal NTP control messages, which NTP hosts can exchange just for some kind of internal NTP purposes, and they're called control queries or something like that. And they have nothing to do with the actual clock synchronization, all right? And there is another type, which is called requests and updates, and they actually deal with the clock synchronization. So, and they are treated differently by each of these access groups. And out of this list, the most permissive group is peer. Peer actually permits router to respond to NTP requests and accept NTP updates, right? So basically, and this is the only mode which allows the local router clock to be synchronized, right? So only this mode allows the local clock synchronization from an external source. Also, this peer mode allows this first type, the control messages or control queries. So let's find a matching statement for it. Time synchronization requests and control queries are allowed. The device is allowed to synchronize itself to remote systems that pass the access list. And I think this is the correct match for this peer statement. Time synchronization requests are allowed and control queries are allowed, right? As well as responses, updates are allowed, I guess. And device is allowed to synchronize itself. Okay, so these are actually updates. Okay, so this is good. The next option is serve, and what serve does, it permits router to reply to NTP requests, so to have external systems times synchronized with the local clock, but it rejects updates, right? So it serves time to others, but it will not take in time from others. This keyword only allows synchronization requests. This keyword only allows control requests. And actually, this serve mode, it is the next permissive mode after the peer, and it will allow these control queries as well. So the router will be able to synchronize other systems and respond to other systems' control queries. And I think this should be this option. Time synchronization requests and control queries are allowed. The device is not allowed to synchronize itself to remote systems that pass the access list. And this is the very good statement for this mode. Okay, and the third method in, again, kind of more restrictive, increasingly restrictive list is serve only. So what serve only will do, it will be responding to requests for synchronization from external systems, but it will not allow the access control queries, right? So, and this keyword only allows synchronization requests. There you go. And then finally, there is query only. There is actually no any time synchronization possible if the external system IP address matches this access group statement. So there will be no any requests or updates going anyway in either of the directions. But this second type of NTP packets will be able to exchange, so queries will be allowed. The keyword only allows control queries, so this is just for control queries. I don't really know the details, what specifically control queries do and what the request update does. Well, request update does obviously the time synchronization, and queries, control queries, they do some kind of internal additional mechanics in NTP, I guess. So that's at least how I understand that. I think that should be the correct answer. Which severity level indicates that a system is unusable? So this is the most serious severity level, and it is called emergency, and it is also number 0. Alert, critical, error. Critical, I think, is the next level of severity, or maybe alert, or error. No, I think they are actually going in this order. So alert, and then critical, and then error. Yeah, but anyway, the most severe level is emergency. You want to control the severity of the event that determines when a syslog should be sent. Which command do you use? Okay, I think this is the logging trap command. Not very straightforward, not very intuitive, I guess, but it is what it is, right? Logging trap and then severity. That's the indication. Which SNMP recommendation is not valid? Okay, I need to search for the not valid recommendation. Always use MD5 authentication when SNMP version 3 is not available and you are forced to use SNMP version 2C. Does SNMP version 2C allow authentication? Does it allow authentication? I don't think so, right? I don't think it allows. Actually, you have to use SNMP version 3 to authenticate your SNMP requests and traffic. Okay, let's see other options. Restrict access to read-only. This is a very good recommendation. Actually, SNMP is not widely used for write access, so it's only used to collect information from devices. Set up SNMP views to restrict the manager to only access the needed set of MIBs. And this is also a good guideline. So we don't export or import all information from the system, from the SNMP agent, but only specific MIBs which we need to have. Configure ACLs to restrict SNMP access to only known managers. This is also a good recommendation, right? So I will stick with my choice of option 1 because MD5 is not available for SNMP version 2C. It is only available starting with SNMP version 3. Okay. What is the SNMP trap message used for? Okay. It performs a write to a MIB variable on the agent. No, this is not what trap is used for. It traps an agent into performing a device reboot. No, it does not. Trap is not an SNMP message. It is an SNMP message. It is a type of SNMP packet. It transmits an unsolicited condition from agent to manager, and that's exactly the correct definition of a trap, right? So a trap is a tool or message which is used by the agent, by the monitored device, to send something out of the blue to the manager saying, hey, something has happened or something is happening. Maybe my memory is running out, or maybe I'm running out of a disk space, or whatever configured or pre-configured trap is there has been triggered. Okay. When you configure flexible NetFlow, which three components must be defined on the local device in order to implement NetFlow on an interface? Okay, there was a very nice illustration in the course for this. I should go through that pretty smoothly, I hope. So the first one is NetFlow export, and export defines what is the IP address of our NetFlow collector. So where will the NetFlow data be exported? Okay. Then the second thing, which is defined, it is NetFlow record, and NetFlow record specifies the format of NetFlow messages which will be exported. What are the key fields? Are they called key fields? I forgot how they are called, but they're kind of they are key fields, right? And then non-key fields and different commands used for this. So using this set of key fields, the system will determine the uniqueness of each flow, and it will group or aggregate the data in terms of packets and bytes collected and counted up according to the unique combination of the values of these key fields, right? And then there are non-key fields, and this information from this field, it will just be added to the data set, but it will not be used for aggregation. Okay, so anyway, that's how record is defined. And then finally, the third step is to define NetFlow monitor. And NetFlow monitor actually brings these two together, right? So it brings the export and record together. And then actually the one extra step which is needed to be done is to select an interface and apply this monitor to the selected interface in a specified direction. In which NetFlow configuration step do you associate a NetFlow record with a NetFlow exporter? As I have just described, it is the configure and monitor step. Just other options, configure record, configure exporter, no. These are kind of created independently from each other, and then they are brought in together when you configure the monitor. Apply FNF to interfaces. I have no idea what FNF stands for. And verify the configuration is obviously not a configuration step, it's just a verification. Okay, and the last question is, which Cisco iOS feature allows you to create your own event definition for a network device and specify the action that should be performed in response to that event? And this is the EEM. And EEM stands for Event Manager. I forgot what another E is, but anyway, it is Event Manager. And it's a very flexible, there is a really nice lab in the course. It's a very flexible tool to kind of utilize and take advantage of the built-in event system in the Cisco iOS. It has a lot of flexibility. You can write scripts which basically reacts to different events, such as something has happened, maybe interface is down, or maybe we have a change in our routing table, or maybe there is a syslog message with a specific pattern emerged, or maybe somebody is trying to input a command, like maybe reboot a device. And then you can associate different actions with these events, such as maybe ignore the command input, or maybe send an email message, or maybe generate a syslog message, and things like that. So it's a really, really powerful tool.